Okay. Hopefully this thing will be nice today. Alright, 5.4, analyzing graphs of polynomial functions. Alright, first line is just a review. What are the zeros of a polynomial? So they're called? Good, x-intercepts. That's what we call when they touch the x-axis, right? X-intercepts. So anytime I say zeros, that's what I mean, the x-intercepts. Okay? And what we're going to be talking about today is multiplicity. So each zero or each x-intercept has a multiplicity. And it refers to the number of times that its associated factor appears in the polynomial. So, for example, if you had this quadratic and it's in factored form, kind of like the one we did with the bell ringer, we've already factored it. It's x plus 3 and x minus 2. Your zeros or your solutions would be at where? Negative 3 and 2, right? These each occur once, and the reason they both occur once is because we're going to look at the exponents. What is the exponent of this binomial right here? Somebody said it. 1, right? And what's the exponent of this binomial? Good. That's why each of these zeros or answers occur once, and we'll talk about what that means in a second. So to find the multiplicity, you just look at the exponent. Okay? The degree of a polynomial in factored form is all the multiplicities added together. We know the degree in standard form, right? Like if I gave you this one, write this up here. This polynomial. What would be the degree? 7. Good, because it's in standard form and it's the highest exponent. Well, when it's in factored form like this, we're just going to take all the multiplicities and add them together. Okay? That's how you find the degree. So for 1 through 3, we're going to find degree, zeros, and multiplicities of each of these, and these are all in factored form, as you can tell. Let's start by finding the zeros. And zeros are your what? X-intercepts. How will we find the zeros of these? How did we find the zeros in our bell ringer once it looked like this? We set it equal to what? Same thing. So we're going to take x plus 1, set it equal to 0. So this 0 is going to be what? Negative 1. What's this 0 going to be? 2. What's this 0 going to be? Negative, what'd you say? 1/2, right? I'll write that one out. 2x plus 1 equal to 0. We'd have to do what first? Subtract 1. 2x equals negative 1. So we divide by 2, so x would equal negative 1/2. So these are all our zeros, which means that each of these spots, they touch the x-axis at those points, right? Alright, now we're going to talk about the multiplicities of each one. So for this binomial x plus 1, what is the multiplicity of it? It's just the exponent. 2. So put mult 2, unless you want to write out multiplicity a bunch of times. So at x equals negative 1, the exponent of this binomial is 2, so it has a multiplicity of 2. What would be the multiplicity of x equals 2? Good. And what would be the multiplicity of x equals negative 1/2? Good. Any questions about that? Let me zoom in some.
So the multiplicity is something with degree.
The degree would be all those multiplicities added together. So the degree of this factored polynomial would be what? 4. Good. You can write that over here. Degree of this one would be 4. Because 2 plus 1 plus 1 equals 4. Alright, any questions? Pretty easy. Alright, question. For number 2, this 4 on the outside, does that affect where it crosses our x-axis? Yes? Why?
Because like if it's like negative, it'd be like reflection.
Yeah, it'd be upside down. You're right. But would that affect where it crosses the x-axis? It just affects the slope, right? Not the x-axis. So we don't have to worry about it because, again, it doesn't affect the x-intercepts. Also, there's no x beside it. So we just leave that one alone. On this one, what would be our 0 for x plus 4? Negative 4. Good. Let's go ahead and list the multiplicity. It'd have a multiplicity of what? Good. This x would be what? 2. And it has a multiplicity of. So what is the degree of this polynomial? Good. That's it. Go ahead and do number 3 on your own. Then I'll call on somebody. Does the x on the outside affect where it crosses the x-axis? Yeah, right? This one didn't because it's a what out front? Just a coefficient, right? Which affects the slope. This one has an x, right? So it does affect our x-intercept. So we're going to set this out on the outside equal to 0 as well. So if we set what's on the outside equal to 0, our x would be what? Yeah, how do we solve for x right here? We'd have to divide everything by -1. What's 0 divided by -1? 0. So we have 3 x-intercepts for this polynomial. Alright, Dylan, what's the multiplicity for x equals 6? Good. Perry, what's the multiplicity for x equals 1/4?
2.
Seth, what's the multiplicity for x equals 0? What's the exponent?
Oh, 1.
Good, that's it.
Okay.
So John, what's going to be the degree of this polynomial?
6.
Very good. That's it. Any questions about that? Alright, let me zoom out some. Alright, so let's talk about how the multiplicity looks like on the graph.
Hey, why don't you do the x equals, or negative x equals 0?
Out here?
Oh, go. Do that. Alright.
Okay. So let's talk about what multiplicity looks like on a graph, why we have to describe it, because it's going to help us to graph it. So any zeros that have an even multiplicity, go ahead and write that. And this is not a mathematical term, this is just something I made up to help you remember. Okay, anything or any zeros that have an even multiplicity will have a 0 that kisses the graph. Okay, like when you kiss a person, so here's 2 people. When you kiss a person, they kiss and then they bounce back, right? They can't go, their faces can't go through each other, right? They just kiss, bounce back. Alright, so that's what it's going to look like on the graph. So even though it touches the x-axis, the 0, it won't cross it. So this is what it'll look like. Say if we're, well that one has a, alright, say if this was 4 instead. Go ahead and draw your graph, draw an x-intercept at 4. And let's say that has a multiplicity of 2, so it has an even multiplicity. Then this is what it would look like. It would hit the graph here, but it wouldn't go through the x-axis, it would just bounce back. Does that make sense? It kisses the graph. It doesn't go through it. That's kind of ugly, sorry. So here's another example. Draw one at 0. And like I said, it'll kiss the graph. It won't go through it. It'll just bounce back.
So it's like a parabola.
Kinda, yeah. It won't always look like a parabola. Like, for example, well, I'll do this one first. Any zeros that have an odd multiplicity will touch the x-axis and break through it instead of kissing it. So if we had another one at 4, and it was an odd multiplicity, so multiplicity of 3 or 1, it would hit the x-axis and also go through it. Does that make sense? Okay. So don't write this one down, but let me show you an example with even and odd. Say if this one had an even multiplicity, this one had an odd multiplicity, so it's going to kiss it right here, right? And then it could keep going and go through it. This one's even because it bounces off of it, doesn't cross it. This one's odd though because it goes through the x-axis. So that's what it would kind of look like on a graph. Alright, we have talked about end behavior. We know what that is, correct? So now let's talk about an odd degree positive leading coefficient, how that would affect the end behavior of the graph. So here's an example of a polynomial with an odd degree and positive leading coefficient. Let's say 2x cubed plus 2x plus 1. Let me zoom in some now. How do we know this is an odd degree? The degree of this one is what? Because it's the highest exponent. How do we know it's odd? Because 3 is an odd number. Alright, so the end behavior of all polynomials that have an odd degree and a positive leading coefficient is going to be this. We always know that there's going to be a left and right side of the graph, correct? So we'll always have x going to negative infinity and positive infinity. So basically with end behavior, all we're describing is your y. And instead of y, we say what? F of x. Thank you. Alright, so if it's odd and a positive leading coefficient, as x goes left, y is always going to go down. And as as x goes right, f of x is always going to go to positive infinity. And here's the easy way to remember this, because you are going to have to memorize it. Positive means like people would agree, right? If it's a positive situation, two people agree. Notice how these are the same. So that's the easy way to think of it. Also, we know odd degrees, these always have to be different, right? The f of x. But just think odd, positive, okay, these are going to agree, these are going to agree. That's the easy way to remember it. And now let's kind of just sketch what this would look like. So we don't know the zeros or anything. I just want to show you the end behavior. So on the left side of the graph, y is going to be pointed down. Everybody see that? Left side of the graph, y is going down. The right side of the graph, y will be going up. So that's kind of how the end behavior will look like on one of these polynomials. Any questions about that? Alright, so from now on, you don't even have to have a graph when you're describing end behavior. Because if it's odd and it has a positive leading coefficient, it will always be this end behavior. Always. Alright, now let's talk about if it's odd but it's negative leading coefficient. So somebody give me an example of an equation. You can just make up one. It's got to be negative. So negative 5x to the what? We could do what else? Yeah, we can do to the fifth. We can get crazy. Alright, notice again, odd degree because of the exponent, negative because of the negative leading coefficient. Alright, so the end behavior is just going to be the opposite. We know we're still going to go left and right on your graph, except this time f of x will be going to positive infinity. F of x over here would be going to negative infinity. So same thing here, we just swapped up the f of x's, if anybody noticed that. Because the negative is going to flip it, it's going to reflect it. And an easy way to remember this, in a negative situation people don't agree, right? See, notice how these don't agree, your x and y, and your x and y here don't agree, so that's an easy way to remember it. And here's how the sketch will look. If it's going to the left and positive, it's going to be like this. And if it's going to the right, y is going down, it'll look like this. And we'll talk more about that in a second. Any questions about that? Alright, flip it over. So now let's talk about even degrees. Even degree, positive leading coefficient. So, CJ, give me an example of a polynomial with an even degree and positive leading coefficient.
2x to the 4 plus 3x squared.
Okay, that's fine. Notice that the degree of this is 4, it's even. This is positive, so we can go ahead and start. The end behavior will always have, again, a left and right side of the graph, so this will always be what you'll have. Notice the end behavior for odd degrees, the y is different, right? So we know with even, they're going to be what? The same, right? F of x has to be the same. So with even degree, it's going to start out with f of x going to positive infinity on both sides. And you can think even, positive, so both of the f of x's will be positive. And here's what the graph will look like, or an example. We know x squared looks like a parabola, right? But let's talk about what x to the 4 is going to look like. So it could be like, there we go. As long as both sides on each side, the left and right, both of your y's end up going to positive infinity. Alright, even degree with a negative leading coefficient. So, Chloe, give me an example of one of those. Okay. I'll just do -2. Alright, so in behavior we'll always have x and y, x going to the left and right. This time f of x will be negative, so going to negative infinity on both sides. Easy way to remember that is even always has the same, and if it's negative, both of them will go to negative infinity. And since you picked a parabola, we'll use that as the example. Notice how y is going down on both sides, left and right. Alright, I know that's a lot to take in, but we're going to put it to practice now. So let's go back to 1, 2, and 3 on the first page, and I want us to use what we've already found to describe the end behavior. Okay? So for this first one, is this an odd or even function? Even, because the degree is what? 4. So it's an even function, so we can write even up here. Now we have to find out if it's going to be a positive or negative leading coefficient. The only thing you have to look at is the first numbers of each binomial. Okay, so this is positive, right? Positive, positive. So this will be an even positive leading coefficient. Alright, so now let's describe end behavior. We'll always have x and y, or x going to the left and right, correct? So we can go ahead and write what? Rondell.
You write x to negative infinity.
Good. On this side?
X to the positive infinity.
Good. Alright, and if we go back, even and positive, that's right here in our notes, even and positive. So what are the y's going to be doing? Positive infinity on both of them, right? And that's it. Any questions about end behavior? What if it was even and negative? Then it would be both, if it's even and negative, it'd be both of them going to negative infinity. Alright, 2 more, or let's do one more together actually. Is this even or odd for number 2? And what would the leading coefficient be? Positive or negative? Good. If you can't tell, this is what? Positive, this is positive, so 3 positives make a positive, right? So this is odd and positive.
Wait, so what makes it odd and even is the degree?
Yes. So Seth, we're going to start out with what?
Would be negative infinity, or no, positive infinity.
What's going to negative or positive infinity?
I'm so lost doing this.
It would help if you flip over and write it down. Alright, Bersida, what's going to be our, what do we start with every time? And, alright, Tatiana, for this one, odd and positive, where's our f of x going to go? Good, negative infinity. And Jada, for f of x going to positive infinity, or excuse me, for f of x, where's it going to go? Good, sorry.
So the top will be the same as the bottom. That makes sense.
If it's odd and positive. Alright, do the next one on your own, number 3, and then I'll call them sign.
Think about when you're multiplying negatives and positives together. Like this first term is negative, right? This first term is positive. And so if you multiply a negative and a positive number together, you get what? And if you multiply, now bring this down, a negative and positive together, so that would be it. Think about if you multiply them together. So this is a negative number, right? This is a and a. So if you were to multiply a negative and a positive together, you get what? Good. And now bring this down. If you were to multiply this negative and a positive, you get what?
Anybody need more time? Okay. Alright, so Chloe, what would be is it even or odd for number 3? Good, even. And Emma, would it be a positive or negative leading coefficient? Good. Any questions about the negative or positive? The easiest way is you just look at the first, you're not worried about the number, right? Just the sign. So this would be a what? Negative. This would be. So think if you were to multiply a negative times a positive number, you would come out with a what? A negative number. So that's all you have to do. Alright, so Kaylee, tell me what the end behavior would be. Good. What would go under negative infinity? Help her out. Good. And if you look under here, notice this one's odd degree negative leading coefficient. My finger's like delayed. Okay. It would be going to positive infinity than negative infinity. Easy way to remember it is if it's negative, they don't agree, so these will be different. Questions about that? Yes.
Isn't it in even, though?
Oh, thank you. Yes. So this would be, you're right, Kaylee, my B. So it's negative infinity, and this one would also be what? Thank you.
Yeah, I was thinking, so I was like,
Thank you. I was thinking odd. Okay. Now we can get on to the fun stuff, graphing. Then flip. Alright, so the only thing we need to graph it are the zeros, multiplicities, and behavior, which we already know how to do all of those. Let's start with the zeros. How many zeros will we have in this one? 3. And where are they at? -3. And any questions about how we got those?
So zeros are like the exponents.
Not the exponents. Your zeros are your what?
Go ahead.
x-intercepts.
Oh,
Okay, so go ahead and draw those on your x-axis. So you'll have one at 1, 2, -3, one at -4, you'll have one at 2. Alright, the reason this says sketch is because we're not actually going to be very accurate. We're just giving an idea of how it will look, okay? That's why it says sketch and not graph. Once we find the zeros, now let's talk about multiplicities. What's the multiplicity of this -3? Of -4 and 2. So this would make this what kind of degree? Odd or even? Odd. And would it have a positive or negative leading coefficient? Good. So as x goes on the left side, f of x is going to go to what? And as x goes to the right side, f of x will go to what? Positive. Alright. Remember, the multiplicity tells you if it goes through the graph or if it kisses it, correct? Okay. Will any of these kiss the graph? How do we know?
because like, if this has got a 0 or something like that, right?
No.
Oh,
Good. Why wouldn't they kiss the graph? Good. All of these have odd multiplicities, so that means as soon as it hits the x-intercept, it goes through it. It won't bounce back. Alright, where's our end behavior starting with on this side? Y is going where? So it would look like this, right? We can start there. We know that on the left side it's going to go to negative infinity. Everybody see that? And right here we don't know how high it's going to go, but we know it goes through it, correct? The 0, because it has an odd multiplicity. So it's going to go through it. It's going to hit this one at this x-axis, go through it. It's going to hit this one and go through it, and look where it ends up, going to positive infinity, just like we needed it to. Alright, I know that was a lot. Any questions? I'm going to go back through it one more time. We drew our zeros, so we know it crosses at that place, those places. The end behavior starts out going to negative infinity on this side, so we need an arrow pointing down. All of these have a multiplicity of 1, so it goes straight through the dots. It doesn't come back and kiss it, okay? Goes straight through it, straight through it, straight through it, all the way up. Now, could you draw your graph like way down here and all the way back up? Yeah. We don't really know where this turns. We're just trying to sketch it, how it might look, okay? Any questions? Alright, let's do one more together. I'll let y'all pick which one.
3.
I knew you were going to say that. Okay. Odd polynomial with zeros at these places, right? So we can go ahead and graph dots on all these places. So 1 at 0, 1 at 2, 4, -3, -5. It doesn't give us multiplicity, right? So we're just going to assume that all of them have a multiplicity of 1. That's what we'll assume. Okay? So is any of them going to kiss the graph? No, they're all going to go straight through it. This says it's odd with a negative leading coefficient. So tell me what the graph's going to do on the left side, Perry. Where's f of x going to go to? Remember, if they're negative, they don't agree. So it'll be positive infinity. And this one will be what, Dylan? Good. If it's odd, they'll be different, right?
like, what would change it, like, if x goes to negative infinity, but the other goes to positive infinity, right?
This one?
Yes, ma'am.
You'll always have a negative infinity and a positive infinity for the x, because you'll always have a left and the right side of the graph. You'll never have something that just starts at 0 and just goes on the right side, unless it's piecewise. Okay, so from this side, we're going to start over here. Does my arrow need to be pointing up or down over here? Good. Who said down? It doesn't matter who said it. But anyways, it's going to be up because it's positive infinity. So we know the arrow is going to be pointing up. And then it goes straight through this one, right? Crosses the x-axis, crosses again, and goes all the way to negative infinity, which we needed it to for the right side. Questions? Alright, once you do 2 and 2 on your own, raise your hand so I can check it. If you do it correctly, you can pack up. No homework tonight.
Which number, please?
Both. If you need help, just raise your hand. I'll come help you.